The temporal query cache maintains a set of previously computed results indexed by query signature and execution timestamp. Each cached entry stores the result payload, the time at which computation completed, and metadata describing the underlying data dependencies. The cache layer operates between the query planner and the execution engine, intercepting requests before they reach the storage subsystem. All timestamps are recorded in UTC with microsecond precision. Time to live configuration is expressed as a duration parameter in the cache initialization struct. The default TTL value is 300 seconds. TTL may be specified globally during system startup, overridden per query class through the query hint mechanism, or set dynamically via the Administrative Control API. Fractional seconds are supported through floating point representation. TTL of 0 designates a result as already expired at insertion time. Freshness bounds define the acceptable staleness window for a given query result. When a cache lookup occurs, the system compares the elapsed time since entry insertion against the freshness bound. If elapsed time exceeds the bound, the entry transitions to the stale state and is marked for eviction. The freshness check completes in constant time via direct arithmetic on timestamps. No secondary data structures are consulted during validation. The cache employs a 3-state model for entry lifecycle management. Upon insertion, entries enter the fresh state. As time passes and freshness bounds approach, entries transition to the warning state. Once elapsed time exceeds the TTL threshold, entries move to the stale state. Stale entries remain in the cache structure until the eviction background process removes them. State transitions are idempotent. Dependency tracking associates each cached result with a set of table names and column identifiers that contributed to its computation. When a write operation modifies any track dependency, the cache invalidation trigger fires. All entries dependent on the modified table are immediately transitioned to the stale state. Dependency information is stored as a sorted list of qualified identifiers. Lookups against this list use binary search. Explicit cache invalidation is triggered by invoking the invalidate by dependency function with a table identifier and optional column list. When column list is omitted, all cached results depending on that table are invalidated. When column list is provided, only entries whose dependency set intersects with the provided columns are affected. This mechanism allows fine-grained control over cache coherence without full system flush. The background eviction process runs at configurable intervals, defaulting to 60-second cycles. During each cycle, the process scans the cache hash table in sequential order, evaluating the freshness of each entry. Stale entries are removed and their memory returned to the allocator. The scanning operation does not block concurrent cache reads or writes. Scan progress is resumed from the previous position on the next execution. Cache hit probability is influenced by the chosen TTL value and the distribution of query inter-arrival times. Shorter TTLs reduce average entry lifetime and increase eviction frequency, lowering hit rates, but improving result freshness. Longer TTLs increase the window during which results remain valid, improving hit probability at the cost of potential staleness. The optimal TTL balances expected freshness requirements against observed query patterns. The query signature is computed by hashing the normalized query text and parameter values. Normalization converts all whitespace to single spaces and applies lexical case rules appropriate to the SQL dialect. Parameter values are serialized to canonical form before hashing. Identical queries with identical parameters produce identical signatures. Signature collisions are handled through chaining with secondary comparison. Memory accounting for cached entries includes the result payload size plus internal overhead for metadata storage. Each entry allocates space for the query signature hash, insertion timestamp, dependency list, and state tracking bits. Total cache memory consumption is capped by a configurable limit parameter, defaulting to 512 megabytes. When this limit is approached, the eviction process accelerates its cycle frequency. The warning state provides opportunity for proactive refresh behavior in cache-aware client applications. When a result in the warning state is requested, the cache returns the cached value, but also sets a hint flag in the response metadata. Client applications observing this flag may choose to issue a fresh query to obtain updated results. The warning threshold is set to 75% of the configured TTL. Cache statistics are maintained in thread local counters to avoid lock contention. Counters track total hits, total misses, total evictions, and current entry count. Statistics are aggregated at configurable reporting intervals, defaulting to every 60 seconds. Aggregated statistics are written to the monitoring subsystem in a structured log format. Per query class statistics are also maintained when query tagging is enabled. Concurrent access to the cache is coordinated through a reader-writer lock. Multiple reader threads may traverse the hash table and retrieve entries simultaneously. Write operations, including insertions and dependency-based invalidations, acquire exclusive lock access. The lock implementation uses spinning with bounded back-off on contention-heavy workloads. Lock acquisition timeouts are not supported. Cache cold start behavior occurs when the system initializes or when the cache is explicitly flushed via the clear all function. During cold start, no cached results are available, and all queries execute against the underlying storage system. Cache population occurs gradually as queries execute. The warm-up period typically spans several minutes depending on query volume and result sizes. Serialization of cache state for persistence is triggered by the checkpoint mechanism. Cache entries are written to a structured binary format including query signature, result payload, insertion timestamp, and dependency list. Checkpointed state may be restored following system restart. Checkpoint files are compressed using standard deflate compression. Restore operations validate checksums before loading entries. Configuration of the temporal query cache is performed through the configuration file or at runtime via the API. Key parameters include default TTL duration, memory limit, eviction cycle interval, and dependency tracking mode. All configuration changes take effect immediately without requiring system restart. Invalid configuration values are rejected with detailed error messages. Default configuration provides reasonable behavior for typical database workloads.